Okay, thank you, Han, and thank you guys for being here. Not rushing to the beach or napping on the very first day. Okay. Anyway, I'm Sean Ma from the University of Notre Dame, and this is a joint work with Arizona State University. Weird. Okay. Oh, or to that. This one. Okay. Nowadays, many apps in Google Play contain ads, and the app promotion ads are those ads that are used to promote other apps. According to Google research, 1/3 of all users discover new apps through app promotion ads. And below is an example. In the red rectangle, you'll see an app promotion ads. While you click it, you will be directed to Google Play to download the app, which is Facebook. In this ecosystem, ad provider create ads, they make ads, and they upload it to ad libraries such as Google AdMob. And the app developers integrate these libraries into their apps. In this process, ad content is invited by the ad library. However, app developers can make their own ads, which we call them custom-made ads. They just directly put those ads into their apps. Therefore, those ads are not vetted by any party, such as ad library. So these app promotion ads can be exploited to promote malware. This is an example, a dictionary app from English to Czech. And while the user wanted to listen to the pronunciation of a word, the user will click the sound icon. However, while the icon click, a full screen ad will pop up said, "We found 23.6 GB of junk files on your phone, and if you believe that, click that. You will be redirected to Google Play to install the app," which is very popular, downloaded more than 100,000 times. However, according to the Google reviews, this app is actually a scamware. It contains aggressive ads, and it claims to be a security software to clean your phone, but it actually does nothing but try to lure users to pay for subscription fee. Manually verify the ad content is quite expensive and impractical, even for those large companies. So can we automatically detect malware promoted by app promotion ads? So to gain a deeper understanding of this system, to answer this research problem, we have to first conduct a preliminary study from two data sets, Andrews and Rico. We have two findings. First, custom-made ads are both prevalent and risky. 23 of all ads are custom-made ads, and 51 of them promote malware. And the ad content of both ad library and the custom-made ads are requested from the server at runtime. So we find that applying static analysis on ad libraries is not sufficient to detect malware promoted by ad promotion ads. And this is our solution. In this ecosystem, apps are cross-promoting each other, like using ads. And this relationship can be naturally modeled using a graph. We call it an app promotion graph, where edges are ads and the nodes are apps. The right side figure shows an example of a real-world app promotion graph, where you can see the icons are apps, and the connectors or edges are ads. Means there is ads in the source app promote the target app. Using this graph, we can capture app promotion relations and the app attributes with information from app market, security vendor, and the binary code. In this way, we can turn the task of malware detection into node classification. Namely, we just classify the node, whether it is a malware or benign app. So our approach we use both dynamic UI exploration and graph learning to detect malware promotion. We first use UI exploration to collect ads and construct a graph. In the graph, we apply graph learning to detect malware promotion. And for the first part, we develop an ad-oriented UI exploration technique. It has three processes. It first apply a deep first search to navigate through the UIs containing ads. And after we got the UIs of ads, we use some text patterns which are empirically crafted to detect ad content. These patterns such as like the more apps, download, install, start now. And because ads are constantly updating themselves, they are dynamically requested from the server, we iteratively restart the app to capture this dynamically updated ad content. And for the second part, existing work only use app attributes to detect malware. As you may be familiar, they use such as API calls or some feature derived from the binary code. Apart from that, our approach also uses the promotion relations extracted from the app promotion graph. And we extract them, represent them, and combine them with attributes to detect malware. So starting from 36,000 seed apps, we have constructed an app promotion graph consisting of 18,000 ads, which are edges, and 6,000 apps, which are nodes. And the results also show that our approach beat other techniques in constructed app promotion graph. Okay, and for malware detection, we have reached overall accuracy of 97.74 and 95.31 F1 score. And interestingly, by including the promotion relations, our approach had achieved a performance scan of 5.17% in F1 scores. Okay, here are the interesting findings. First, we find that malware promoted by app promotion ads are prevalent. Popular ad networks are exploited to spread a variety of malware. We find 520 malware promotion ads. The promoted malware includes adware, Trojan, fleeceware, and so on. And 2.64% of all ads promote malware. We think this is a large percent because we talked at the beginning of our slides, 1/3 of all users discover new apps through app promotion ads. Considering this larger user base, this rate is quite risky. And we also find the promotion tactics exploited by developers to promote malware. For example, promotion chain. Malware are not usually promoted by benign apps. They are actually promoted through some middleware. We call them potentially unwanted apps, PUAs. Developers will also craft a flagship app, a very high quality and popular apps. They upload it to App Store, and this is very popular. They attract a lot of download, and developers use those flagship apps to promote their other less popular malware. They would also exploit non-code app makers to create a massive of adwares and storm the app market to promote malware. And we also conduct a temporal analysis. The previous experiment results are all derived from the February's experiment, and we now, 6 months later, we conduct an experiment in August. We started from the same source node, the source apps. We record their ads, and we try to explore the difference of the derived app promotion graph. So we have two interesting findings. The first is zero-day apps, which are new apps found in the August experiment. We never saw them in February's, and we found 119 of them, and 18 of them are malware, with already millions of downloads obtained in this half year. And we also find 28 late detection malware. They are benign according to virus total in February, but become malware in August. And surprisingly, all of them can be detected by our approach early in February. We thought they are positives, but they are not. So we also conduct in the wild case study. We construct a tiny little app promotion graph from two seed apps, which are parroted video apps we encountered in our previous study. We just run them, record their ads, download the promoted apps, and run the promoted apps, record their ads, so far and so forth. Finally, we got an app promotion graph of 37 nodes, and 21 of them are malware, including gambling, porn, Trojan, adware. All of them are promoted by custom-made ads instead of ad libraries. And this shows the potential of our approach to study underground economy. Okay, that's it. I'm very happy to take questions. Thank you.
Hi, Elijah Bama Sims from Carnegie Mellon University. You spoke a little bit about you gave the framing example of like a security tool download. I'm wondering if you could speak more about what sort of social engineering techniques were prominent. Like, were these purporting to be games? Were these purporting to be security software? Like, what did you look at? What was common? Thank you.
You're asking what social engineering technique are they used to promote malware?
Yeah.
They just for example, they would create Facebook profiles to promote those malware, and they also craft fake user reviews to extract download.
Okay. I guess I was curious about what the apps purport to be like commonly. Like when you say they're app promotion ads, so they're being directed to download an app that supposedly does something. What is the like supposed functionality? Is there commonalities in that, or?
They're supposed to be normal apps.
Okay.
You can use every.
I guess the question. Sorry. I guess the question is about what kind of apps they are pretending to be. Is it like a banking app, or is it like a gaming app? Or
No, they do not pretend to be anybody. They just be themselves, but they hide in these ads.
The one you show is the antivirus software.
Can't hear you. Can't hear you.
Oh.
No. You want to comment?
Come to the microphone, yeah,
Oh, yeah.
if you can. Yeah.
So I think the one that you show on your first slides is the one that pretended to be an antivirus.
Yeah, antivirus software.
Yeah. So he was asking what kind of fake functionality.
Okay. They claim to clean your phone, clean all the trashes. That's the fake functionality.
Besides that,
No, that's all.
Okay, next question then. Yes, we have. Yeah.
So I was wondering, how do you differentiate the advertisements that come from libraries from the advertisements that are actually custom made?
They are using ad libraries such as Google Ad Mob, for example, and Facebook Meta Ads, Unity 3D.
Right. So how do you, I mean, so you have the app, right? You're navigating the user interface and clicking on things. How you know, like the advertisement that shows up, whether it was generated by a library or like or by custom-made?
You have two sources. One is from a library, and one is just custom-made ads. They just write the hard-coded ads. Okay.
Okay, thank you.
Thank you for the presentation. My question is, how does your work compare to work on clickjacking? Clickjacking.
Our work is this is a very good question. Our work is we focus on the mobile side, and I think there are two different directions. The ads lure user to click it. They use some encouraging patterns that, like download me, install. So users click them themselves instead of being hijacked.
Yeah, I mean, clickjacking is basically you trying to click on something that is not like what you thought it was, right? So
Yeah, so there are no clickjacking.
Okay.
So yeah, basically what he said is that it's not a clickjacking. It's just the real link actually is.
You just click
supposed
it
to
and
be
download it.
Yeah.
I have one comment for the second question. So essentially, how do we know it is an ad? Is essentially you click and then you will jump to an app store and then download. Then we will know it's an ad. Otherwise, we don't know. Yeah, right now. Yeah, thank you.
Thank you.
All right. Thanks the speaker again. All right.